Hi all. Today I'm going to talk about the basic theory of significance testing. So a significance test is a formal procedure for comparing observed data with a claim. And in significance testing, there are two hypotheses that you'll use. There's a null hypothesis, which is a statement of no difference that's tested as if it's true, and an alternative hypothesis, which is a statement of difference. So in this example, let's say that there is a tutoring group that meets every day after school for kids in third grade for their reading scores. And we are hypothesizing that by going to this reading group, students are going to improve their reading scores by the next test. The null hypothesis would say that there would be no differences in reading scores between those who go to the tutoring group and those who don't. The alternative hypothesis would state that there is a difference between the two. So in this example, let's say that the students that went to the tutoring group, their scores increased on average of 3% between test 1 and test 2, and that the group that did not go to tutoring increased by 1% between test 1 and test 2. So in significance testing, essentially what you're doing is you're looking at the null hypothesis, which is the statement of no difference, and you're seeing what's the probability of this actually being true. And if it's highly unlikely that it's true, then you can accept the alternative hypothesis that there are differences. So the p-value is the probability computed, assuming that the null hypothesis is true, that the statistic would take a value as extreme or more extreme than the one actually observed. So basically, assuming that there are no differences, what's the likelihood that this would happen just by chance, that the group that went to tutoring got better by a certain extent that they did? So if this happens like perhaps 1% of the time just by random sampling, you would say that it's unlikely that this occurred just by chance, and likely going to the tutoring group has been helpful. So small p-values are evidence against the null hypothesis because they say that the observed result is unlikely to occur. So if it happens, say 1% just by chance, that would be a p-value of 0.01. Generally, the cutoff for p-values is 0.05. So 5% of the time happening by chance is what the field generally does. But there are different cutoffs depending on what you're doing. So our conclusions of significance tests comes down to these criteria. A small p-value, you reject the null hypothesis, which is the statement of no difference. So if it's highly unlikely that these scores would have improved to the extent that they did from the tutoring group just by chance, you would reject the null hypothesis. And you would conclude the alternative hypothesis, the statement of difference, which can be written in several ways. In this one, we said that the tutoring group would have higher test scores, but you could also say that it would have lower test scores, or it would not be equal to the other group. But in this one, we're doing higher scores. If the p-value is large, if the p-value is greater than 0.05, you fail to reject the null hypothesis because you don't have enough evidence against the null hypothesis. Therefore, you cannot conclude the alternative hypothesis that there were increases in test scores. So this is the basic idea of significance testing. Thanks for watching.